Today's lesson's over section 3.6, where we will talk about inverse trigonometric functions and their derivatives. Here I have a warm-up problem that we're going to go over first from the previous section. So using implicit differentiation, we want to be able to find the x values of all the points with horizontal tangent lines of the following equation. Okay. So looking at this, I'm going to take the derivative of all these values. Now, here I really just have to use power rule for each one of these. But notice that each one that I have y with, I'm going to take the derivative with respect to y. So dy is after. And then on the right side, there's all x's. So I take the derivative of each one of those with respect to x, so dx. Now I'm able to factor out the dy and the dx for both sides. And then that allows me to solve for dy over dx so I can find the derivative. So I divide by dx to both sides, and I divide by what is multiplied to dy from the left. And so then that gets me my derivative. Now once I have my derivative, I can kind of separate that from everything. And since I'm looking for horizontal tangent lines of this function, where all the x values are, that means I'm looking for slopes that are equal to 0. Okay, so I'm going to set this equation, or this derivative, equal to 0, and then I'm going to solve. Now, I have to multiply by the denominator, which means that I'm going to be able to cancel out all the y values, and so it's really just the numerator equal to x, and so then now I need a factor, so I can pull out a 2x out of everything. The trinomial inside the parentheses I can factor, so I get 2x minus 1 times x minus 1. And then I can set all of those equal to 0 and solve. So then from there, I'm able to get that x is equal to 0, x is equal to 1/2, and x is equal to 1. And those are all the x value points that have a horizontal tangent line at those ordered pairs. Okay? So for inverse sine function, here I'm showing you how I get those. Now, the process is basically the same for all three of these, and that's the top line there. So I'm going to have to use a Pythagorean identity to help me kind of switch things around, and so that I can get either cosine of y, sine of y equal to something, but then I refer back to a previous statement to help me find this. And so inverse cosine and inverse sine's derivatives are very similar. So inverse sine is 1 over the square root of 1 minus x squared. Cosine is -1 over the square root of 1 minus x squared because of the derivative of cosine and sine, because cosine involves negative sine, sine involves just positive cosine, so that's why there's a negative and not a negative in each of those. And then for tangent, it's very similar as well, but it has a different trig function that it's pulling from, because it's 1 plus tangent squared equals secant squared. So there's no radical when you have to solve, and so since it's already equal to secant squared, so then tangent's derivative, or inverse tangent's derivative, is 1 over 1 plus x squared. Okay. Also notice that for sine and cosine, they have a domain restriction because of the square root in the denominator. That's why it's from -1 to 1, and tangent doesn't. So here I'm going to take the derivative with these. Now this is not involving implicit differentiation like right off, because y is by itself already on the side, so we're really just looking at the derivative with respect to x. So I have e to the inverse cosine of x for the first one. So I take the outside and then the derivative of the inside, and that gets me the following answer. Letter B, there's product rule between x squared and the inverse tangent function. So I take the derivative first times the second, derivative of the second times the first, and simplify as best as I can. Here you don't have to make denominators with those, because it won't get you anything better than that statement, basically. And then at C, this is a chain rule of 3 functions. So the outermost one is to the 4th power, the next middle, or the middle one, is the inverse trig function for sine, and then the smallest, or the most inner one, is x squared plus x. Okay, so I take the chain rule of 4, that gets me to the 3rd, then 1 over the square root of 1 minus the inside of that squared, and then the inside, which is 2x plus 1. Okay, have fun.